So the conversation you're about to hear, the background information is the client has a door and frame. They need the door to go to 180 degrees, but the distance, or what would be considered really the clearance dimension in the formula for wide throw, is extremely larger than normal. The wall, for the sake of just using round numbers, let's imagine that the client has a 12-inch thick masonry wall, but they're biasing the door towards the push side of the opening. They're flushing that frame with that 12-inch wall. They're not flushing it to the outside of the 12-inch wall, maybe 9-inch wall, let's say. They're flushing the frame out here, but they want the door to open to go to 180 degrees and be held open in that position. So what needs to happen is the vertical axis of pivoting needs to get moved way over in order for the door to not only go to 90, but go all the way to 180. And it's because of how deep that wall is, and it's because of where they're positioning the frame within the depth of the wall. It creates a situation where you can't go to 180 with a standard hinge, which is why we went with a wide throw hinge. A 12-inch wide throw hinge requires an accommodation in terms of the width of the door, and we'll go through you'll hear the conversation then, because I'm not confident that what has been manufactured is going to work. I'm actually going to AutoCAD this myself, because I did receive shop drawings from the client, and what's in the shop drawings is not what was said completely, or was just in a disjointed fashion. But I want to make sure that my client's going to show up to the job and it's going to work just exactly the way he needs it to work. And let's move on. Architectural Builders Supply is pleased to present you with this recording of the technical question that is listed in the title of this video.
This call may be monitored and recorded for quality assurance.
You know, a lot of people call and they say, yeah, remember when we discussed this? The answer is no, I don't. And even if I did, you know what I mean? I think your father and I discussed how wonky 12-inch wide hinges are and the accommodation that needs to be made in the width. Maybe him and I never did. But a conversation should be had with a door manufacturer about 12-inch wide hinges because of the accommodation that's needed in terms of door bevel or door width when you have such a wide hinge. It throws the pivot axis way out. Do you want me to call your door guy and talk technical with him? Do you want to call him and three-way it, or do you want to do something like that?
Yeah, I can three-way it. I just, I'll tell you, I think they already have the door manufactured, but all right, let's give it a try.
It's better that they catch it. It's better that this discussion's had before it shows up and you're there with your hammer.
Okay, I'm going to add the call now.
Yeah, let's do it.
Okay, stand by. Okay, Rad, we have Richard from AC Supply in Florida on the phone.
How are you?
Okay. Hey, how are you? Good.
Good. So the thread type for that BB11, whatever it is, 68 or 99, that's just a regular 1224.
1224?
Yeah.
Okay. 1220, that's what I needed to know.
Yeah. But I wanted to talk. I didn't realize the door was being made specifically or whatever it was. It's been months since those hinges shipped. So has there been any conversation about the fact that they're 12-inch wide hinges and how that hinge width has a particular, because that vertical axis of pivoting is kicked out so far, it has a very particular concern about the prefit size. Meaning, if you've got a 3.0 door and you use a 35 3/4 or 13/16, that is not going to work. That door's got to be made smaller because of that 12-inch wide hinge, because of how far that pivot point is out. Has there been discussion about that?
No.
Okay. So tell me, what is the door and frame made of?
CRS. It's made out of CRS and cold roll, and then it's made out, of course, clad in the stainless steel.
Okay. Okay. So how thick is the stainless steel?
the stainless steel is 20 gauge, and
Okay.
the CRS that was used is 16 gauge.
That's heavy stuff. Okay, so how was 5 by 12 hinges specified to you at the time the order was placed for the door and frame?
Yeah, that's what that's what was told for me. Yes.
Okay, so after you get wider than 10 inch, the 1/8 of an inch or 3/32 pre-fit is no longer going to work. 10 inch is theoretical that it's going to work. Any thermal bow might make it a problem. 12 inch is absolutely not going to work with a standard pre-fit. So the two ways to solve that is to give it a much greater than 3-degree bevel, if it's beveled at all, or you're going to have to reduce the width of that door by, and I have this all in AutoCAD, so I can send
but I think it was given to me. So we did exactly the specification had the way you guys sent it, the new way done. So it has the bevel. In the front, it has the bevel in the back, and we just have the placements of where the thread is going.
What's the net width of the door?
The net width of the door is the width of the door. You mean the size of the opening of the door?
No, sir. How wide is the door? The actual net width of the door?
It's 1 3/4 inches.
That's the thickness.
And then the wide is what was it? 35. What was it again? I don't have it in front of me.
Hold on one second.
It's what it was, 35 3/4 or something like that. I think it was.
Is it a 3/0 door?
It's not. It's the 32-inch opening, and I believe we made the door 35 3/4 on the outside. The latch side bevel is 3/16, and the hinge side bevel is 1/8.
Correct.
So you're saying that
I can't open the shop drawing right now on my phone. I'd have to be in the office.
So are you saying that you all allowed a 3/16 gap between the lock style of the door and the jamb?
Yes.
Okay.
In the back side. So we beveled it by 3/16 on that latch side, yeah.
All right. So how I heard 32. Is this a 3/0 door? Just 36 inches the inside width of the frame?
Yeah, that's what it's made.
Okay.
It's made larger just for the door stop. For just to make sure for the stop. The opening is 32, but it's obviously larger just to accommodate their opening where it's sitting at.
What's 32 inch?
The actual opening of the entrance.
The opening of
okay. Sorry, I got it confused.
So the opening is 32. So what you mean, like a rough opening that you're going to install the door and frame into?
It's already been installed. That's the actual opening of the actual walkthrough. And now when we install this door, which now, as a matter of fact, it has a 36-inch opening. It's a 36. They took a quarter off. That's what was taken away.
Okay, so you have got a 36-inch wide frame, and you took off a quarter inch, so your door is 35 3/4.
Correct.
Okay, it's not going to work. That door is too wide for a 12-inch wide hinge.
All right, I think this conversation was supposed to be had before we manufactured the door.
That's why I asked you 5 minutes ago if the hardware was specified to you when the door was ordered. So when Matt called this morning to ask the 1224 question, I said, hey, by the way, I mentioned his father and I may have had a conversation months ago. I don't recall. But if you were told 12-inch, the bottom line is 12 inch is a real gnarly animal. So do you guys have AutoCAD or something like that you can rotate?
Well, we put it on CAD, and the architect approved the adjustments that we're speaking to right now. They put it on CAD, and he was actually the gentleman or team who said that a 3/16 bevel on the latch side will work. And if we have the door 35 3/4 and 36 opening, it'll work.
So rather than an 1/8 of an inch in 2, you all made it 3/16 in 2?
No, 3/16 on the latch side and 1/8 on the hinge side.
But I'm not understanding what's 3/16. If it's a 3/0 wide,
3/16. Yeah, what it is that they did the face of the door that faces the outside is 35 3/4. Now the inside portion, take off the 5/16, the 8th on the front, the back side, and the 3/16 on the other side. So that's why it's like a bevel. So it becomes smaller. That way you can picture it in your head.
So the definition of bevel is 1/8 and 2. It sounds like you changed that to 3/16 in 2. So that very likely will solve the problem. The relief on the bevel on the hinge side, not going to play such a role. Actually, I think it might make it more problematic because putting a bevel on the hinge side,
it's going to be an issue.
It's going to be an issue. That hinge is not, the swag on the hinge is not meant for a beveled edge door. So
I've always thought about that because it's flat. It's not going to be like they're both going to be perfectly flat. It's always going to look like a V. A little opening all the time, correct?
Yeah, exactly right. And the problem is that hinge, because of its width, is going to really jam that hinge way out, is what it's going to do. So I would re-AutoCAD that. You know, when I say AutoCAD, I mean someone's drawing the object and rotating it. So I would redraw it with a beveled edge door, using the full mortise hinge, the Hager BB, whatever it is, 1199 or 1168, and then I would see what that looks like again, because
But I think John did that, right, Matt? I think John did that. That's what he did.
I'm of the understanding that John did that. I was actually I got on a Zoom meeting with him months ago, and they did the CAD operation on the computer screen right in front of us, and they were of the mindset that this was going to work.
Yeah, the issue is the bevel, because the hinge is not swagged. The leaf is not swagged or bent for a beveled edge door. It's like when you use swing clear, you have to know if they're beveled edge or square edge doors. I would say not less than this. Hang that door in the jamb before it goes to the job site with the hinges to make sure it swings. I'm thinking it's not going to. In fact, I don't think the door is going to open at all.
Well, the frame's already grouted in on site. We were trying to bring the door to it and install. Right on. Yeah, I would. You want me to call the architect and make them run the CAD again?
Hey, Matt. I think, I'm sorry, guys. I'm sorry to interrupt. But at this moment, at this time in the game, I think we're gonna have to try it out first, man. Let's try it out first. Cross our fingers and hope it works. If it doesn't work, then we discuss plan B, because at this stage in the game, the door's already been made. And let's try it out. I mean, John did he did actually do the job. I remember speaking to you guys when you guys spoke to me about that. And this is where, the other person was doing your door.
Yeah. All we're looking to do is to make sure Matt doesn't show up there and has to go home a half an hour later. That's all we're trying to do. That's all.
Yeah, I think we're going to have to try it out first. It's already been made.
Yeah. So I can, I would have your guy rerun AutoCAD. I would have him call me if he wants to talk about why he's rerunning it. And it's because of the beveled edge. The 3/16 bevel very likely will work. So let's go from there. Let me know, fellas, what happens, and let me know what I can help with.
Not a problem.
All right, I'm gonna let's just keep moving forward, I guess.
Okay.
What did we say the tap was? 1224.
It's 1224. Yeah, definitely. Yeah, it doesn't change to quarter 20 until I think it hits above 6 inch and above. I think I'd have to look, but not 5 inch hinges.
All right, so 1224. All right, let me just get on this, guys. All right, thank you, fellas.
Thank you, gentlemen. Bye-bye.
All right, let me reach out to Rich and John. All right,
bye.
Thanks. Information. We made the overall width of the door 35 5/8 in lieu of 35 3/4.
Yeah, that should work, but it's more of the bevel on the hinge side that I'm concerned with.
So what I'm thinking to do is call Radimex and ask him if he can allow for fabrication of some kind of custom stainless steel bushing that'll offset that hinge properly.
That's all he's got to do. The problem with that is The problem with that is the high side of the door is where the accommodation would have to be made. So you'd have to cut into the door on the pull side for the hinge and mortise that abnormally deeper, so that the small side of the door, the hinge would be flush closer to the small side of the door, which would be the push side. I would like it if he would just take a stock 3.0 frame, and just, give yourself, just three pieces and just knock them together. Don't weld it, and just lay it flat and put that door in there and try to lift it up and out just to make sure that it clears. Is what I think what would be really nice, or you do that before you go to the job site.
Yeah, because my team's kind of like talking about bringing this thing on site and giving it a try, more or less.
Yeah, that's it has to be tried somewhere. It's just it's hard to beat a door with a piece of 2x4 and a hammer, a 4-pound sledgehammer. You don't want to be doing that in the field. This is, you're gonna, your tools are going to be there, your truck's going to be there, you're going to be triple parked, the whole 9 yards.
All right. Okay, I'm going to call the door vendor and keep moving forward. But you feel better now that the door is 3.35 and 5/8. We gave ourselves a little more room.
Yeah, but if it had a square edge on the hinge side, I don't recall my AutoCAD that I did. I'd have to revisit that video. But I'm really confident. I'm very comfortable that it's going to work fine with that much prefit. The other issue is the 3/16 bevel on the edge of the door. You know how, and if you have that as well, in addition to the 1/4 inch, I'm really sure it's going to work. Actually, those two together, it should be really good. But like hardware, and what I mean is lock sets. So if you ever held a latch bolt in your hand, the faceplate wiggles a little bit. It's not rock solid, because if the latch bolt on a cylindrical lock or a mortise body, if those mounting tabs were fixed, you wouldn't be able to install them on beveled and square edge doors. So they make it so that you can install that hardware on either type, and they make the latch bolt faces float. The issue is they're not meant for a 3/16 bevel. They're only meant for an 1/8 of an inch bevel. You'll be able to probably make that work, but the aggressive bevel on the edge of the door solves one problem but potentially creates another, and that means getting hardware installed, because hardware is not meant for that aggressive of a bevel.
We're using a surface-mounted strike with the Dorma exit device.
Oh, you're fine. It could be a 10-degree bevel. No, you're fine. That's perfect. Awesome.
Right. Yeah. Nothing.
Yeah.
The panic device is not mortised, actually. So.
Awesome. Yeah. Awesome. Yeah. So a heavy bevel and a 1/4 inch, and I would try it because what you could possibly, I don't want you to have to put that hinge in a vise and then start to try to re-swag the hinge leaf to bend it slightly. Like McKinney makes hinges that are literally just meant for beveled edge doors, where they got one leaf that when you bring them together in the closed position, one leaf has got a 3-degree bevel on it. It goes away from the other leaf to account for that.
Sure.
Okay, so I think we've done a lot to address it showing up and it being a fail. It's hard to bend that type of hinge when you're whacking on it. So you might want to do that before you go to the job site, or at least not be there, because you got a barricade up, I imagine. So I would test that before you go through the effort.
Okay. All right. Okay. All right. So that seems positive. We're gonna keep moving forward. So if you wanted to bend the hinge, you just put it on a vise in the shop and and
feed on it.
what's just hit it with the 4-pound mallet.
Yeah, I wouldn't really want to do that at all. And if I was going to actually try to bend that leaf, I would probably bolt a vise to a steel column and then, use a really long lever.
Sure.
Now, there are hinge swagging tools, but it's literally just Cro-Magnon trying to bend the hinge leaf.
Right. Kind of need a machine on those,
Well, if you're doing one, it's no big deal. But you've got 3 to do, and they all have to be the same.
Right. 4 actually.
4. Okay. Well, there you go. Yeah. And that was, that question I asked the fella. He's a super nice fella, but I needed it to be stated. I needed to know who told the guy to make it for those hinges because. Either he wasn't told or he was, and
no, he was told.
Yeah, so okay.
He knows, but I think between all of us, between Franco as the GC, the architect, the door and frame vendor, we're all a little bit in a new world with these huge hinges. So we tried to make all of those provisions that we just discussed, and we're hoping it's going to work.
Yeah. Absolute worst case scenario is that it's a new slab before they put the 20 gauge stainless cladding on it, and so that you can just adjust that bevel on the hinge side. That should be the absolute only thing that would worst case scenario have to happen. Just a new slab.
Yeah, well, I'm pretty sure they already, put the door together. They're at the point where they're just drilling and tapping the holes on for the hinges.
Yeah. Well, yeah, it would also be a good idea to swing it in the shop before it gets put on the delivery truck, because when you're doing that much hand labor, just lots of opportunities for something to be off a little bit. It's just lots of opportunities.
Yeah, I would have to get him the hinges. They're in my shop. All right, I will call and discuss.
Thank you, sir.
Thank you, Richard.
Bye-bye.
Bye now.
Architectural Builders Supply hopes you have enjoyed this program. Okay, let's take a look and see what we have here. I'm going to set up AutoCAD so that it works the way that I would like for it to work, and I'm not going to record all of this with all of the edits. I will pause this and probably just condense this into a complete finished view. If you are enjoying this video, please click thumbs up or like, and also please consider subscribing to our channel. Let's move on to the rest of the video. Okay, Matt, what I've done here is I've created a scenario, and the scenario is per the shop drawings, where I've got a 35 5/8 wide door, and I've got 1/8 of an inch on a beveled edge door. I've got 1/8 of an inch here. For the shop drawings, I've got 1/8 of an inch over here. I've got a 3/16 bevel on this one, and I've got 1/8 of an inch bevel on this side. So let's select our door. And let's rotate it. Let's select our pivot point, which I have positioned correctly. Now let's rotate this. Probably not unlike what you're going to need to do to get that door held open. But of course our concern is over here. It's pretty tight. That gap is 50 thousandths. That's here, I bet. .044, so 44 thousandths. So that's just not going to swing. Now that is based on the hinge not forcing the door out. So if you had a square edge, the bevel over here doesn't matter. I didn't need to draw it with a bevel. But step 2 of this is showing what's going to happen to the door when I take a hinge let me show you. What I'll do is I'll draw it in here and show you what's going to happen. If you've not hit subscribe yet, we would very much appreciate if you did, and hopefully you're enjoying this video. Now, let's get back to it. So Matt, I've got some additional lines drawn here, and what we know absolutely is here's the template of what we're dealing with here, and 5 by 12. Okay, so a 5-inch heavyweight hinge is going to be 190 thousandths is actually what it's going to be. 190. So it's a pretty thick hinge. So what we know absolutely is the hinge is going to occupy the space from the face of the frame back 190 thousandths. That's absolute. This leaf is going to be straight up to the barrel. And the fact that I didn't draw it correctly here just doesn't matter. I mean, it's going to have a bend to it. But we know, actually, if I drew, what would fix that is just increasing the diameter. Diameter, let's go, what is the diameter? E, the E dimension is 47/64. Does that work? Yeah. So the bottom line is we can get in here, trim that. So, I mean, the hinge is going to look more like this on the one leaf. The problem is when we space the second leaf over according to the center line and then put a 3-degree bevel on it, which is what would have been done, the dimension here, it's close to 190 thousandths, even though it's probably 160 thousandths would be my guess. Distance. $173 thousandths. So the hinge is not, the hinge is going to push this over automatically 15 thousandths. So a 64th of an inch. No big deal. But already, we're going to hit already. So it's moving it over. The real issue, however, is when you try to take 190 thousandths and get it flush back here. So it's not going to be flush back here, is the bottom line. We come to where our hinge needs to be down here, and we come over 190 thousandths. It's going to be coming off. The hinge won't be flush with it, is the bottom line. So best case scenario is it moves the door over, not theoretically another 64th of an inch. The hinge is going to kind of look like going to kind of look like that down here. Okay. Reasonably is what it's going to look like. Now, I'm not an AutoCAD expert, and this is not to the 64th of an inch accurate, but it's to within a 32nd of an inch accurate. My point is you referred to the shop drawings. I have looked at those, and based on what's in the shop drawings, it's not going to work. It's going to hit. Now, if the actual door manufacturer deviates from the shop drawings, then you might be okay. Meaning, how was the door manufactured? And, you know, what's the deal? The deal is you're my customer, and you know, I want to make sure you guys are good by the time you show up. And your door guy sounds like he's super awesome. So if there's a mistake, he's going to fix it. And that company, I think, is owned by Long Iron Fireproof Door. Those guys have been in business for decades. And, you know, every interaction I've had with them has been always great over the years. So based on what I'm looking at, I don't think it's going to work. And I would swing that door before going to the job site. And let's swing it just for the sake of swinging it. Rotate. Select your vertical axis of pivoting. Oh, what did I do? Rotate, select your object. Select your base point here. Let's do it again. And I didn't shift the door over at all, but there's just no need to do that. So that's what we're concerned with, is that 44 thousandths of an inch. Thermal bow, you know, that door swelling because of heat. Yeah. Anyway, I'm not trying to solve. I'm not trying to create. I'm trying to solve problems, and hopefully this helps. Thanks. If you've made it this far into this video, you must be determined to see it through to the end, and we appreciate your hanging in there with us and watching this entire video. It means a lot. It takes a lot of work to create these videos in the sense that, you know, it's time taken away from doing other things. However, the advantage for me personally of creating these videos is the fact that it does allow myself to either learn about something new, to reacquaint myself with something, or to reinforce what I believe that I already know. Any comments that you might leave down below would be greatly appreciated. Thank you. Okay, so hopefully that reasonably reflected what to expect with this application, proving that there's going to be a problem based on the information that we have. You don't want to find that out when you're at the job site. The door is going to need to be made. What I would actually do is I would make the door. So what would I do? I would at least, I would remake the door with a square edge. And I would shrink the width of the door by, well, the issue is making the door smaller is not an answer, because now you've got a really excessive gap. The issue is with a 12-inch wide hinge, that's what you're dealing with. So the client stated, well, he said it was an exit device. Why in the gospel? Okay, yeah. It's a path of egress. Door's going to be held open all the time unless for some reason it's closed in an event of an emergency, but you can still exit that way. Because the stop is 5/8, you know, you can kick the door back. You know, you're not going to really see it. It's obviously no security unless when it's closed. If it's exit only, there's no re-entry, and what they could do is put an offset astragal, an offset bar astragal on the pull side, and that will certainly always cover that gap. You won't see it from the push side, so I would reduce the width of the door. I'd probably take it down 3/16, an additional 3/16 is probably what I would do. Remake the door with a square edge. on the hinge side, and I would reduce the door. I would still do a heavy bevel, a 3/16 bevel for sure, maybe even 1/4 inch, and I would reduce the door size by maybe 1/8 of an inch, depending on what type of bevel that they put on there. But before I remade the door, I would actually replot that in AutoCAD and see what it told me to do. So 1/8 smaller, 3/16 or 1/4 inch bevel, and that means 1/8, 3/16, 1/4. If you take a space of 2 inch, you've got if you take a rectangle that's X wide and 2 inch tall, the width doesn't matter, and 2 inch tall, and you draw a right angle triangle. Let's switch to AutoCAD to do this. Regarding the links to ads that you might see in this video, we do apologize for any interruption to a smooth viewing experience, and hopefully the ads that are being presented to you are related to the base product. And if there is something, feel free to click on those and perhaps consider taking a look at what that other advertiser is promoting. Let's get back to the video. Okay, what we're drawing here is, what we're illustrating here is what is bevel. Line, (2" 90, 10" 0, 2" 90, 10" 180. Bingo. Now, this is a 90-degree angle. (90°). These two objects, they're at 90°. Now, if I want to illustrate bevel, the definition is 1/8 in 2 is the definition. And what that means is for every 2 inch in thickness you have, which we have 2 inch thick, that bevel is going to be 1/8 of an inch over, which translates to 87°. So here we're going to go over sorry. I'm going to get better at this. We were at line, yeah, here's 1/8 of an inch. Let's do this. Here is 3/16 of an inch. Here is 1/4 inch. Away from this edge. So, line. So the definition is 1/8 in 2. So that means that this is what I'm going to look like on a 1/8 in 2. So my bevel is going to be smaller by 1/8 of an inch for every 2 inches in thickness. So if we were to put a heavier bevel, the client put a 3/16 bevel, that would come over to here. So he's going to have an extra 1/16. Maybe put a 1/4 inch bevel on it. It's going to come over to here. So it's the difference between the Y line and the tangent line is what that would be called. And these degrees change every time, obviously. Let's see if we can take a look at that. Angle. Source object here and here we know is 90°. Source object between here and here, 94. So it should be, you know, yeah, that's relatively close enough. It came up with 94. So the source object between here and here, 95, and then, you know, whatever, you know, probably 96. So that's what we're defining as the bevel. The greater dimension that you change it, the more relief you have, which is going, and the point of the matter is to resolve what's happening, right here. to resolve that. Okay, let's wrap up this video on camera. So solving the problem hopefully is what we achieved, and eliminating the guesswork beforehand is really what we're trying to do. There's no reason to show up to the job and not know that things are going to work. Not in this day and age. Not with the tools that we have available to us, with the knowledge that we have available to us, with the expertise we have available to us, with the understanding of the manufacturing process that we have available to us, with the understanding of what installers go through in the field that we have available to us. This is not going to work the way it's been manufactured, and it will have to be corrected. Thank you very much. Again, thank you for watching, and if you've enjoyed this video, please click thumbs up, please subscribe, and maybe even send the video to someone that you know. Thank you.